the United States, China, or Brazil dominate global agriculture through sheer scale and output, then Japan, with only 12% of its land suitable for cultivation, still ranks among the most valuable agricultural industries on the planet. Every year, Japan produces over 60 million tons of agricultural products and food, with quality regarded as a global benchmark, generating tens of billions of US dollars annually, despite high production costs and a highly volatile yen. But how can a country where up to 70% of the land is mountainous, and which constantly faces earthquakes, storms, floods, and severe natural disasters, carve out such a distinctive position on the global agricultural map? In this video, join Agriculture Insight as we uncover the secrets behind the uniqueness and high value of Japanese agriculture, where intelligence, refinement, and absolute precision have turned adversity into a massive economic advantage. Everything will be revealed right now. More than 45,000 hectares of specialized farmland are dedicated exclusively to tea cultivation, concentrated mainly in Japan's midland and mountainous regions such as Shizuoka, Uji, Kyoto, Kagoshima, and Aichi. Despite accounting for only a very small share of the country's total agricultural land, the green tea industry generates hundreds of millions of USD annually for Japan. Rather than pursuing mass production, green tea has risen to become one of the 4 high-value pillars of Japanese agriculture, alongside rice, premium vegetables, and specialty fruits. It has helped Japan maintain its #1 position globally in matcha and firmly assert the prestige of Japanese agricultural products on the world market. The secret behind the vibrant jade green color and the irresistible umami sweetness of Japanese matcha lies in its shade-growing technique. About 3 weeks before harvest, artisans cover entire tea fields with layers of black netting or straw, blocking up to 90% of sunlight. In the darkness, the tea plants are pushed into survival mode, forcing them to produce a massive amount of chlorophyll to absorb the scant remaining light. At the same time, this process drives a sharp increase in amino acid levels, creating the matcha's signature calming effect. The result is a tea leaf with highly concentrated nutrients, an almost mesmerizing green hue, and a smooth, gentle sweetness, something no tea grown under direct sunlight can ever replicate. During the harvest season, typically in early May, the intelligence of Japanese agriculture is clearly demonstrated. To meet the global surge in demand, with more than 2,000 tons of tea exported to the United States each year, specialized tea harvesting machines from popular lines such as Valiant and Ochi have become the key for Japan to optimize production. Operating by enveloping entire rows of tea plants, using curved cutting blades to create a uniform dome shape, and simultaneously employing high-pressure air streams to blow freshly picked leaves directly into collection bags in an instant, each machine can process over 1,000 kilograms of green tea per hour, fast, consistent, and efficient, while still maintaining the quality standards required for industrial processing. Once inside the factory, the tea leaves are immediately steamed to lock in their color and halt the oxidation process. After being air-dried to become tencha, the most delicate step begins, removing the leaf veins. All stems and veins are completely discarded, leaving only the purest part of the leaf. This is precisely why Japanese matcha powder is always silky smooth. Finally, the product is finished using massive granite stone mills. To preserve its highly sensitive flavor, the stones must rotate extremely slowly to prevent heat from altering the aroma. It takes a full hour of continuous grinding to produce just 30 grams of powder, so fine that it seems to melt instantly upon touching the tongue. Despite competing with low-priced matcha, Japan maintains its position through extreme meticulousness. This craftsmanship has pushed the price of premium tencha to 56 USD per kilogram, while ceremonial-grade matcha can reach hundreds of dollars for just a few dozen grams. Despite not leading global rice production like Thailand or Vietnam, Japan stands out with premium varieties such as Koshihikari, valued for their exceptional stickiness, subtle aroma, and natural sweetness. The journey of creating glossy rice grains begins with meticulous care right from the sowing stage. Instead of direct seeding into flooded fields, farmers use standardized plastic trays filled with loose, nutrient-rich soil. Once the seeds germinate, seedlings are evenly distributed at precisely controlled densities to ensure ideal growing space. During their first weeks of life, young rice seedlings are strictly protected like in mini greenhouses by covering the fields with white plastic sheets. This layer stabilizes temperature and humidity, allowing the seedlings to grow healthily despite cold winds. When the time is right, the root systems intertwine tightly to form a solid mat, enabling farmers to lift entire sections of seedlings without damaging a single root. Next, these seedling mats are loaded onto automatic rice transplanters. The machine separates each small clump and inserts it into the mud at a precise spacing of 30 centimeters per row. Straight-line planting helps optimize air circulation, ensure even sunlight exposure, and reduce pests and diseases. Although not a rice superpower when it comes to automatic rice transplanters, Japan is currently one of the world's leaders in technology and mechanization. A Japanese rice transplanter, represented by models such as Yanmar, can handle at least 1 to 1.5 hectares per day, working 10 times faster than manual transplanting, a method still commonly used in countries such as Vietnam and India. After about 150 days, when the fields turn golden, modern combine harvesters move in. Compared to combine harvesters used in the United States, Brazil, or Australia, Japanese machines are much smaller, with a capacity of only about 1/5. Yet this compact size is precisely their advantage, allowing them to operate flexibly on Japan's small, fragmented, and soft field terrain. These machines perform a closed-loop process, cutting the rice, threshing the grains, and bagging them directly in the field, while simultaneously chopping straw and returning nutrients to the soil. As a result, a single machine can harvest and thresh 1 hectare of rice in under 3 hours, replacing the labor of dozens of workers. While Thai jasmine rice, widely regarded as the gold standard of Asian rice, sells for around $2 per kilogram, premium Japanese rice is often priced at over $20 per kilograms, distinguished by its plump, round grains, high stickiness, and the ability to retain a rich natural sweetness even after cooling. Many people think grapes should be soft and juicy, but Shine Muscat, a premium peony grape from Okayama, the sunniest and least rainy region in Japan, features a firm, jelly-like crunch and a sweetness reaching 20 degrees Brix, about 1.5 times higher than ordinary grapes. The secret of Japanese farmers lies in calculated sacrifice. From the moment the vines begin to flower, they prune ruthlessly, allowing each branch to retain only a single best grape cluster, forcing the plant to channel all the nutrients, sugars, and essence, originally meant for dozens of other clusters, into one single entity. Not stopping there, they continue to hand-thin each small grape within the cluster, ensuring enough space for the remaining grapes to grow large without being crowded, while allowing air and sunlight to reach every gap. Not only that, each Shine Muscat grape cluster is wrapped in a special paper bag while still on the vine to block insects, harsh UV rays that can scorch the skin, and even rain droplets that may cause mold. This is precisely why Japanese Shine Muscat grapes have smooth, glossy skins that can be eaten directly, without bitterness or chemical residue. When harvest time arrives, instead of cutting in bulk, farmers measure the sugar content of each individual cluster using handheld meters. Only those that meet the standard are allowed to be picked. Each grape cluster is carefully handled and harvested entirely by hand, like a living piece of jewelry. Farmers use specialized scissors to cut each stem with absolute precision, avoiding any movement that could damage the delicate skin. Once picked, every cluster is immediately placed into a cushioned tray to preserve its perfect shape and natural gloss. There is no mass harvesting, no stacking, only meticulous care at every step. With the enormous labor costs involved in meticulous hand cultivation, each premium Shine Muscat grape cluster can fetch 100 to 200 USD at auctions or in high-end supermarkets. Leaving the mainland behind, seafood has become the second front through which Japan has built a luxury empire worth around 2.5 billion USD annually, turning the country into one of Asia's leading sanctuaries for high-end seafood. Among more than 400 commercial seafood species, bluefin tuna dominates the premium segment, making it the most sought-after ingredient in the world of sushi and sashimi. The otoro, the fattiest cut from the belly of a top-grade bluefin tuna, can be priced at 30,000 to 50,000 USD, comparable to a luxury sedan such as a Mercedes-Benz E-Class, and sometimes even higher at early-year auctions. Traditionally, bluefin tuna are caught during the winter season, concentrated in the northern Pacific Ocean, using methods such as hand-line fishing or long-line fishing to preserve meat quality. However, in response to rising global demand and the growing risk of depleting natural stocks, offshore bluefin tuna farms have emerged, with Japan being one of the pioneering countries. These kings of the ocean are raised in massive circular cages in deep waters, where currents, oxygen levels, temperature, and feeding regimes are strictly controlled. Automated feeding systems precisely distribute feed, allowing the fish to grow evenly and achieve an ideal fat ratio. Thanks to advanced offshore aquaculture technology, Japan produces more than 10,000 tons of farmed bluefin tuna each year, with an estimated value of at least 700 million USDs, securing the country's position as the world's #1 producer of farmed bluefin tuna in the global luxury seafood segment. At the auction floor, each bluefin tuna is assigned an identification number to precisely trace its origin, weight, and fishing vessel. The fish are then moved into a deep-chilled auction hall, where seasoned traders assess quality solely by meat color, fat marbling, and firmness before placing bids through subtle hand signals. The highest record ever set was a bluefin tuna sold for 333.6 million yen, approximately 3.1 million USD in Tokyo. Once the auction concludes and the fish belongs to the winning buyer, master tuna cutters immediately begin breaking down the fish the same night, separating each cut with absolute precision to preserve freshness, texture, and maximum value. Leaving behind the heart-pounding auctions at the harbor, we return to land to encounter Japan's culinary national treasure, Wagyu beef, a type of meat known for its painting-like marbling and aristocratic care process. The high price of this beef, especially the top-grade A5, stems from a feeding cycle that lasts twice as long as industrial cattle. It takes at least 30 months to reach full maturity in marbling structure. Throughout this period, the cattle's diet is fully personalized, consisting of a nutrient-rich blend of grains, rice straw, and soybean pulp. Notably, to prevent stress, an element that can toughen meat and reduce fat quality, farmers raise the cattle in an environment of absolute calm. At some traditional Wagyu farms, particularly during summer, farmers give cattle small amounts of beer to stimulate appetite. Alongside this, manual massage is used as a stress reduction method, helping fat distribute more evenly within the muscle fibers. A cow is allowed to leave the farm only when it reaches 700 to 800 kilograms and passes one of the strictest grading systems in the world. Only meat with a perfect fat-to-lean ratio, vivid red color, and glossy texture earns the A5 stamp. Wagyu fat melts at around 25 degrees Celsius, lower than human body temperature, creating the sensation of meat melting on the tongue with a delicate aroma. Each cow has its own birth certificate, with a unique nose print to trace its lineage, and the most expensive cuts, such as ribeye and tenderloin, are served at luxury teppanyaki restaurants or exported to the United States and Europe at prices of $500 to $1,000 per kilogram, making Wagyu a true symbol of Japanese luxury. In the United States, apartment buildings are designed for people to live in. In China, entire 26-story buildings are constructed solely to raise pigs, operating as fully enclosed, AI-driven systems, where each pig rides its own elevator and generates over $100 million in annual revenue. Inside these extraordinary pig apartments, each floor functions as a self-contained world. Breeding floors, nursery floors, and fattening floors, all organized like a massive biological machine running 24/7. The entire process is controlled by AI technology. Every pig is fitted with sensors that monitor health conditions, feed intake, growth rates, and even heart rate. Each pen acts as an individual monitoring station, equipped with touchscreens displaying real-time data for every animal. From a smartphone or tablet, managers can oversee entire herds, tens of thousands of pigs, with just a few taps. Beyond livestock engineers, the system also includes dedicated floors for scientific research. Here, pig farming is no longer manual labor, but a precision industry, where each animal is managed like a device with its own digital profile, tracked down to every gram of feed and the smallest physiological fluctuation. In the past, in many countries, mushroom farming meant leaving harvests at the mercy of weather and seasonal risks. In China, however, that narrative has been completely rewritten. Robots and automated systems now control every link in the chain, from humidity and temperature to each morning dewdrop, all the way to the final cut at harvest, together generating over $7 billion annually. Depending on farm scale and mushroom varieties, different harvesting methods are applied, but all are driven by the same goal: faster, more precise, and more uniform production. On small and medium-sized farms, manual harvesting still plays a crucial role. Workers gently twist the mushroom at its base to separate it from the growing medium, avoiding cracked caps or torn stems. The roots are neatly trimmed, and the mushrooms are placed directly into trays. This approach allows for precise maturity selection, preserves perfect form, and meets the standards of premium mushroom varieties. On large-scale farms, specialized harvesting machines operate as fully enclosed production lines. Blades cut cleanly at the base, mushrooms drop onto conveyor belts and pass through sensor systems that evaluate size, shape, and quality before automated packaging. At the highest level, robots take over the entire harvesting process. Mechanical arms lift mushrooms with millimeter-level precision, cut the roots, sort them on the spot, and operate 24/7, delivering massive output with near-perfect uniformity. As desertification spreads and water becomes a matter of survival, Chinese agriculture has been forced to rethink its choice of crops. Sunflowers, with their deep root systems and low water requirements, have emerged as a strategic crop in Inner Mongolia, Gansu, and Xinjiang, arid regions where many other plants struggle to survive. From late June to July, sunflower fields burst into bloom, painting vast stretches of northern and northwestern China in gold. But their true value only begins once the flowering season ends. By September to October, the flower heads droop, signaling that the seeds have accumulated sufficient oil and are ready for harvest. Specialized combine harvesters move into the fields, precisely separating the flower heads from the stalks, cleaning the seeds, and rapidly collecting them into storage bins. Thanks to integrated mechanization, harvesting is fast and efficient, with minimal loss. In China, sunflowers are more than a symbol of summer's golden landscape. They are a vital source of vegetable oil, playing a key role in securing agricultural stability in water-scarce regions. Chinese agriculture is not only defined by speed and scale, but also by products shaped through patience and precision. Honey peaches are a prime example. Although still cultivated using largely traditional methods, this delicate fruit generates USD 15 billion annually, proving that value does not come from volume, but from quality. Unlike common peach varieties that can be harvested using shaking machines or mass collection methods, honey peaches must be picked entirely by hand. The reason lies in the fruit's unique structure: exceptionally soft flesh, high water content, and thin, highly sensitive skin. Harvesting honey peaches is a refined manual process. Pickers do not twist or pull. Instead, they cradle the fruit in the palm of the hand, gently easing the stem until the peach naturally detaches from the branch. Each freshly picked fruit is placed immediately onto soft padding. A single drop or slight squeeze is enough to instantly destroy its value. In return, consumers are rewarded with a fruit that is delicately sweet, intensely juicy, and subtly aromatic, available for only a brief window of a few short weeks each summer. In China, spicy hot pot is more than just a dish. It is a ritual, and chilies are the fuel that powers its heat. Producing around 16 million tons of chilies each year, accounting for nearly 45% of global output, China does not merely consume spicy food, it shapes the world's map of heat. Few people see the harsh reality behind the chili industry. Manual harvesting, especially for extremely hot varieties, once caused burning eyes, respiratory irritation, low productivity, and heavy dependence on seasonal labor. That is why the world's largest chili-producing nation was ultimately forced to mechanize. In large-scale growing regions such as Xinjiang and Gansu, specialized chili harvesters operate like mobile production lines, cutting plants at the base, gathering them, separating the pods through vibration and vacuum suction, and transferring them directly into storage bins, without human hands ever touching the crop. As a result, productivity has surged, health risks have dropped sharply, and the final product achieves greater uniformity for processing and export. This is not simply faster harvesting, it is a strategic shift that has turned China into a dominant superpower in the global chili industry. When kiwifruit is mentioned, the world often thinks of New Zealand. Yet on the global value map, China is the true center, accounting for over 50% of the world's production, equivalent to more than 2 million tons each year. Behind these figures lies a harvest season governed by extremely tight control. From March to June, kiwi orchards enter their most critical phase. Kiwi fruit is not harvested when fully ripe, but must be removed from the trellis at a precise biological threshold, while the fruit is still firm enough to withstand storage and long-distance transport. For premium kiwi varieties, everything still depends on human judgment. Farmers assess firmness, weight, and the condition of each individual fruit by hand, because a shift of just a few days in harvest timing can dramatically alter the value of an entire season. As kiwi cultivation expanded, manual harvesting quickly became a labor challenge. In large-scale commercial orchards, machinery was brought in to solve it. Sensor-equipped robotic arms move along the trellises, identify harvest-ready fruit, and cut the stems with split-second precision. Each kiwi is supported and placed directly into trays, enabling faster, more uniform harvesting while sharply reducing reliance on manual labor. In China, corn is more than a crop. It is the backbone of an entire agricultural ecosystem. From vast mechanized fields to the livestock and industrial chains behind them, every kernel carries the weight of food security, meat prices, and economic growth. In late autumn, cornfields across northeast and North China turn deep gold, signaling peak harvest season. Combine harvesters roll steadily along pre-planned rows, cutting, shelling, and separating kernels within seconds. Stalks and leaves are shredded and returned to the soil, while sensors and precision controls keep losses to a minimum. What once required weeks of labor is now completed in hours. A single machine can harvest dozens of tons per hour, unloading grain on the move into transport vehicles without stopping. This closed-loop process keeps kernels off the ground, reduces contamination, and ensures consistent quality for China's massive industrial feed sector. For the Chinese, coriander is the soul of thousands of dishes. Once a hand-grown culinary herb, coriander has now entered the era of industrial agriculture, generating over USD 5 billion annually through modern technology. On large-scale farms, coriander is harvested using specialized machines designed specifically for this low-growing, soft-stemmed crop. At the front of the machine, thin, sharp, fast-rotating blades cut cleanly at the base, preventing damage to the leaves. Once cut, suction systems or conveyor belts lift the coriander into collection bins, ensuring minimal loss and preventing contamination. Some advanced machines are also equipped with sensors that detect plant density and height, automatically adjusting cutting speed and height in real time. The entire harvesting process runs continuously and rapidly, preserving the herb's freshness and its signature aromatic oils, key factors that determine commercial quality and market value. This marks a major step forward in reducing labor demands and boosting overall output. First, we step into the world of the rice transplanter, the machine that has overturned thousands of years of wet rice farming history, replacing human labor, once dominant for millennia, with a level of mechanized productivity far beyond human limits. In the past, rice transplanting meant hours of standing knee-deep in flooded fields, bending over to plant each seedling by hand under harsh and exhausting conditions. Today, automatic transplanters have completely changed the game, boosting productivity 5 to 10-fold, covering 1 to 2 hectares per day, with planting depth and spacing controlled precisely down to the centimeter. These machines operate like specialized agricultural robots designed for paddy fields. At the front, seedling trays are stacked in layers and gradually fed toward the planting mechanism, where uniform mats of seedlings are carefully separated to a consistent thickness. As the machine moves forward, synchronized cams and shafts at the rear activate mechanical arms that lift the seedlings, divide them into exactly 2 to 4 plants per planting point, and press them straight into the mud in perfect rhythm with the rolling wheels. This allows each plant to stand upright the moment it touches the soil, forming straight, evenly spaced rows that manual transplanting can rarely achieve. RTK GPS guidance keeps the machine moving in perfectly straight lines with an error margin of just a few centimeters, while depth sensors continuously read the field surface and automatically adjust the planting legs for each section of land. In just 1 hour, the machine can complete up to 2 hectares, while the operator simply monitors the process from inside the cabin. In the past, pesticide spraying was a job that came at the cost of human health, increasing cancer risk by as much as 70%. Today, drones costing around 30,000 USD, flying just above the fields, have removed humans from direct contact with chemicals, turning a high-risk task into a controlled and safer technological process. Before each flight, the exact amount of pesticide is calculated based on field size, crop density, and growth stage. A detailed digital map of the field is preloaded, clearly defining each crop row as well as no spray zones. Once airborne, the drone follows a programmed flight path, while cameras and sensors continuously scan leaf color, canopy coverage, and early signs of pest infestation. Using real-time data, the system automatically adjusts spray dosage, Heavily infested areas receive full treatment, while healthy sections are reduced or skipped entirely. Flying at an altitude of just 2 to 3 meters, the drone delivers chemicals directly into the crop canopy, reducing environmental chemical loss by up to 40%. A single drone can replace 20 to 30 manual laborers, while the operator remains outside the field with minimal exposure to chemicals. In many rural regions across Asia, this technology is not only transforming how pesticides are applied, it is gradually bringing an end to a job once described as trading health for income. There was a time when global agriculture consumed nearly 3,000 trillion cubic meters of water each year, accounting for 70% of the world's freshwater resources. Today, thanks to modern irrigation technologies, crops can grow just as reliably, often even more efficiently, using less than 1/3 of that amount. Water is pumped through precisely calibrated pipe networks and sprinkler or drip emitters, producing ultrafine droplets that fall directly into the root zone, where plants absorb water most effectively. As a result, these systems reduce water use by 60 to 70% compared to traditional flood irrigation, which suffers heavy losses from evaporation and deep percolation. The system also automatically selects optimal irrigation windows, such as early morning or nighttime, cutting water consumption by an additional 30%. Every irrigation cycle is recorded as data, transforming watering from intuition-based practice into a technology-driven process controlled by measurable parameters. The result is that a single operator can manage dozens of hectares, maintaining stable yields even during drought conditions. Water efficiency is no longer a trade-off against productivity. It marks the beginning of an era of precision and sustainable irrigation. For centuries, American farmers struggled to find efficient ways to harvest hard-shelled nuts, such as almonds and walnuts, where each season demanded hundreds of hours of manual labor. Today, modern technology has reduced this challenge to a single, precisely controlled vibration, lasting just a few seconds. The true turning point came with the invention of the tree shaker, opening a new chapter in mechanized agriculture, one in which harvest productivity can increase by up to 10 times compared to manual methods. First, hydraulic arms clamp onto the tree trunk using rubber-lined gripping jaws. These provide sufficient friction to secure the trunk while evenly distributing force, preventing bark damage or bruising. Once the grip is stabilized, the hydraulic system delivers vibration pulses with carefully calculated frequency and amplitude, strong enough to detach the fruit stems from the branches, while keeping the trunk and root system fully protected. All vibrations are maintained within safe thresholds, preventing trunk torsion or root uplift. With just 2 to 6 seconds of shaking per tree, the majority of the yield, up to 90 to 95%, can be harvested efficiently. Extending the shaking time not only fails to increase output, but also places the tree under biological stress, directly affecting its health and the productivity of future harvests. Capable of processing 200 to 300 trees per day, a modern tree shaker can shorten the harvest season from several weeks to just a few days, while delivering savings of hundreds of thousands of dollars per season, fundamentally reshaping the economic equation of large-scale agriculture. Almonds and walnuts require only a few seconds of trunk shaking, but for crops like blueberries or mandarins, everything depends on canopy vibration frequency, where a single, perfectly tuned pulse can cause the entire canopy to release its fruit in an instant. Canopy shakers never clamp onto the tree trunk. Instead, the system embraces entire rows of trees, applying force directly to the canopy through wide surface, elastic vibrating rods that distribute force evenly and prevent branch breakage. Unlike trunk shaking, canopy shaking relies on high frequency and low amplitude, just enough to detach the fruit stems without causing violent tree movement. Many machines operate at 300 to 600 vibrations per minute, allowing the entire canopy to shed its fruit within seconds. Stronger shaking does not improve results. Instead, it can damage the internal structure of the fruit even when the exterior appears intact. Once detached, the fruit never touches the ground. Flexible catching trays, soft conveyor belts, and elastic padding receive the fruit almost instantly, achieving 98 to 99% recovery rates with extremely low bruising. As a result, canopy shakers can process tens of thousands of fruits per minute, replacing 50 to 100 manual workers and placing modern harvesting under a new discipline: precision mechanics, where a wrong frequency can ruin an entire season. Japan is regarded as the capital of freshwater eel in Asia, consuming nearly 100,000 tons annually and turning this slippery fish into a strategic, ritual dish every summer. Eel farms are not only a vital link in Japan's culinary supply chain, but also act as silent biological factories, steadily operating behind the scenes of a refined food culture. Japanese eel sells for $20–40 per kilogram, far more expensive than tilapia and even farmed salmon. Beyond its price, eel meat is prized for its tender texture, rich flavor, and high nutritional value, especially its renowned ability to restore energy and vitality after periods of fatigue. To this day, the reproduction of eels remains a deep-sea mystery. Despite tracking their long migration journeys, humans have never witnessed them mating or spawning in the wild. Everything unfolds silently in the ocean depths, making this fish one of the most enigmatic aquatic creatures on Earth. Because artificial breeding has yet to be fully achieved, modern eel farms still rely on juvenile eels caught from the wild. Once collected, these young eels are placed into specialized tanks within industrial farms, where water quality, temperature, oxygen levels, and stocking density are strictly controlled to ensure growth and minimize losses. Eel tanks in Japanese industrial farms are far more than just bodies of water. They are artificial ecosystems engineered with near-perfect precision. Beneath their calm surface lies a complex network of sensors, water circulation systems, and controls for oxygen, pH, salinity, temperature, and flow, operating silently yet continuously like a living biological machine. And within that artificial ecosystem, the strangest element is the feed itself. To keep alive creatures as fragile as glass threads, Japanese scientists once turned to an unlikely ingredient: shark eggs. Rich in lipids and rare enzymes, these eggs supported the early development of the eel larvae's digestive system. But due to high costs and limited supply, researchers began a race to develop an alternative diet. The answer lay in microbial technology. In the hatchery, each batch of feed begins not with manual mixing, but with a spinning steel vortex drum. Warm-treated water is added, followed by a blend of deep-sea fish meal, enzymes, live probiotics, synthetic fish oil, and seaweed flavoring. As the drum turns, a smooth, sticky nutrient mass forms, cohesive enough to shape into pellets while preserving live enzymes and beneficial microbes. Instead of being dried or dissolved, the feed is incubated in a dark room where humidity, temperature, and light are precisely controlled to awaken the microbiota and trigger fermentation. The final product is shaped into small pellets and placed directly into the juvenile eel tanks. Not dropped haphazardly or crushed on impact, each pellet lands on the water's surface like a programmed biological signal. Its outer coating keeps it from dissolving immediately, while the core softens just enough for the eels to nibble bit by bit. In the swirling water, surrounded by thousands of tiny bodies, each pellet becomes a gathering point. The young eels respond instinctively, gently nudging, nibbling, circling back again, creating a rhythmic dance as if the ocean's energy were pulsing right inside an industrial plastic tank. After about 7 to 8 months of cultivation, once the eels reach optimal size, modern farms initiate a fully automated harvesting process. Gone are the days of scooping by hand. Today's tanks are modular in design, with tapered bottoms and smart drainage systems that trigger the eel's natural reflexes to gather as the water level drops. From there, they are guided through smooth, flexible pipes and delivered straight onto the processing conveyor belt. Due to their elongated bodies, thin skin, and slippery, delicate nature, every stage involving physical contact is carefully optimized to minimize stress and impact. The conveyor belt not only transports the eels, but also gently washes off any remaining mud, cools their body temperature, and stabilizes their condition before moving on to the next processing stage. After preliminary processing, the eels are placed into specialized plastic bags, not to induce unconsciousness, but to retain moisture and create a sealed environment that makes breathing easier during transport. Thanks to their ability to exchange gases through their skin and their unique mucus layer, eels can survive for hours with only a minimal amount of dissolved oxygen, almost as if they were in a state of suspended animation on their way to the processing plant. At the processing plant, the eels are placed directly into large stainless steel washing tanks, where high-pressure cold water continuously rinses away mucus, feces, and any remaining impurities on their skin. Under industrial lighting, hundreds of eels slither through the aeration system like lively ribbons before being transferred to the automatic sorting unit, where slanted mesh panels with varying gap sizes separate them by size. Immediately after cleaning, the eels are transferred into ice-filled containers to induce rapid immobilization. This method causes no harm, instead triggering a natural cold reflex that renders them temporarily motionless. As a result, the eels remain calm, do not struggle or generate heat, and maintain optimal flesh quality before entering the final anesthesia stage. Once cleaned and sorted, the eels enter the pre-processing zone, where exacting techniques are required for every step. In kabayaki production facilities, workers perform traditional butchering using the kanto-style technique, which involves slicing the eel from the back, preserving the belly, and making it ideal for skewering and grilling later on. Workers use a specialized eel knife with a short, sharp blade and a non-slip wooden handle. The eel is secured on a wooden cutting board, fitted with a metal spike to pin down its head, a simple yet highly effective design that keeps the slippery body in place. Within seconds, the eel is slit open from neck to tail along the spine. The backbone, intestines, kidneys, and blood are carefully removed using a flat knife and tweezers, then rinsed thoroughly under a continuous stream of cold water to preserve freshness. After being thoroughly cleaned and pre-processed, the eels continue their journey to the grilling station, where high-temperature technology is combined with traditional know-how to create the signature kabayaki flavor. In the first grilling stage, the eels are evenly arranged on stainless steel racks and placed into a sealed oven, heated to around 230 to 250 degrees Celsius. The main purpose of this initial grilling is to firm up the muscle structure, straighten the eel's body without any curling, and lock in its natural sweet moisture, a key factor in ensuring the flesh remains tender and juicy. This process requires precise control over time and temperature to ensure the outer layer is just cooked enough without drying out the meat during the subsequent steps. After that, the eels are taken out of the oven and dipped into kabayaki sauce, the very soul that brings the signature sweet savory flavor and distinctive aroma to this iconic dish. Once the sauce is thoroughly soaked in, the eels are returned to the oven for the second round of grilling. At this stage, the kabayaki sauce begins to caramelize under the intense heat, forming a glossy amber-brown glaze. A lightly charred, fragrant, and delicately crisp skin develops, adding both visual appeal and a deeper layer of flavor. Each eel is now coated in a shiny, flavorful jacket, ready to captivate diners at first sight. Thanks to the repeated grill-dip-grill cycle, every bite of the eel becomes richly flavored, tender, and succulent on the inside, and beautifully glazed on the outside, the perfect embodiment of traditional Japanese kabayaki. Once the grilling and kabayaki sauce absorption steps are completed, the eels are moved to the packaging area, where every operation follows strict food hygiene and safety standards. Wearing sterilized uniforms, gloves, and face masks, staff carefully place each glossy golden piece of eel into specialized plastic trays, manually inspecting for shape and overall quality. Only those that pass inspection are packed into heat-resistant vacuum bags, then run through an automatic vacuum sealing machine to remove air, extend shelf life, and lock in flavor. The vacuum-sealed eels are then neatly arranged in baskets and transferred to the boxing station, where workers place them into cardboard boxes, apply labels and barcodes, and securely seal each package. From there, these perfectly grilled Japanese-style eels are ready to reach supermarkets, restaurants, and family dining tables across the globe. All eyes are usually drawn to the flesh, the most prized part of the eel. But few realize that hidden beneath its tender meat lies a silent treasure: the bones. Once removed, these bones are far from wasted. They're simmered into a rich, concentrated broth, infused with onions, leafy greens, and various spices to create a blend that's both flavorful and deeply nourishing. In another variation, the bones can even be deep-fried, turning into a unique and crispy side dish. Quietly yet artfully, this seemingly discarded part has become a refined highlight, completing the eel dining experience in the most unexpected way. Just as quietly, another journey begins. Not in the distant open sea, but within the confines of a laboratory. Here, mature eels are injected with hormones, and their eggs and sperm are collected by hand before being introduced into tanks designed to simulate the deep ocean. If fertilization is successful, thread-like transparent larvae are born, replicating the eel's 5,000-kilometer natural spawning journey, all within a space no larger than a few dozen square meters. Immediately after hatching, the larvae enter what is considered the most precious stage of their life cycle, the glass eel phase. At this point, their bodies have just completed structural development, measuring about 5 to 7 centimeters in length, still gelatinously transparent, and so delicate that even a slight change in pH or temperature can wipe out an entire batch within hours. During the first 30 to 60 days, glass eels are raised in brackish or dechlorinated freshwater tanks, where the temperature is kept stable between 25 to 28 degrees Celsius, and lighting is dimmed to near darkness to simulate the conditions of a riverbed. After surviving the highly sensitive glass eel phase, the remaining individuals enter a new chapter, the Elver stage. This is when their bodies begin to undergo visible changes, transforming from a jelly-like transparency to a light brown or murky gray hue. The first pigments emerge, as if to declare they are now ready to face life in freshwater environments. Each individual that develops well during this stage represents a growing unit of value, forming the very foundation upon which the entire downstream production chain can operate efficiently consistently and sustainably. From a small, humble creature, the eel has now found its place in both cuisine and technology. Thanks to human hands working in harmony with modern processes, its value is not only preserved and elevated, but also embodied in the story behind every slice of meat.